Hello students, today I am going to discuss about the Cauchy integral formula. Cauchy integral formula is useful to evaluate certain complex function, actually not integrating it. So what is that one? Let us discuss. Along with that, we will discuss some problems also. So the statements of the Cauchy integral formula says that if f of z is an liquid function, if f of z is an analytic function within and on a simple closed curve C, and A is a point lying inside C, then f of A will be equal to 1 by 2 pi I integration over C f of z divided by z minus A dz. So in other form, we can say the same statement as evaluation of integration over C f of z divided by z minus a dz, and value of this integral will be nothing but 2 pi I into the value of the function f of z at z equal to a. So provided this a is lying inside the simple closed curve C. If this A is outside the simple closed curve C, then the integral will be simply 0. No need to find any value of this one. So I will mention C, what will be the closed simple curve, and you have to check whether the A is lying inside C or outside C. If it is lying inside the simple closed curve C, then we will find the integral is this much. If the point A is lying outside the C, then the value of this one will be 0. So remember that when you are getting the problem like this, the degree of the denominator z minus a is always linear. That one you have to remember, because if it is non-linear, I will talk about some other formula. So apart from z minus a, whatever remaining things are there in this expression, that we will consider as f of z. So z equal to a is the point lying inside C. Then what we will do, whatever f of z is there, in that you replace z by a. So you will get f of a. So simply you multiply that f of a with 2 pi I, and that will be the value of this integral. So this is called Cauchy integral formula. So I will take some examples on this. So let me take first one, simple one. Simple example I will take. Question will be like this. Evaluate integration over C 1 by 2z minus 1, 2z minus 3 dz. Okay. So where my closed curve C is given as mod z equal to 1. Okay. So hereafter you see that what is the meaning of mod z equal to 1. Mod z equal to 1 means, see, first I will give you the explanation of what is mod z equal to 1, then I will go to the problem. say we are always considering z equal to x plus iy. So mod z will be nothing but root over of x square plus y square, and root over of x square plus y square. So in our present problem, mod z is equal to 1, so it will be 1. Now if I take square on both sides, I will get here x square plus y square equal to 1 square. And what is this? This is nothing but a circle with center at origin and radius 1. So it is like a circle where center is at origin and radius is 1. Radius is 1. Okay. So this is the circle. So hereafter, whenever I am talking about mod z equal to something, you understand that that is a circle. That is a circle. Okay. So now here let us solve it. Let us solve it. So let me find the value of a. What will be a? See, compare these two things. Here I should have z minus a, but here I am having 2z minus 3. So in order to make it a z, I have to take 2 common. So I can write this one as integration over c dz divided by, if I take 2 common, what we will get? We will get it, as like this. If I take 2 common, I will get like this, z minus 3 by 2. Z minus 3 by 2. Now 1 by 2 is constant, so we can write this one as integration over c, and I will take that 1 by 2 above, and down will be nothing but z minus 3 by 2 and dz. Now you can easily compare the original formula and the given problem. So original formula says that f of z divided by z minus a. So in the place of f of z, what is the value we are having? Here we can say, here f of z will be nothing but 1 by 2, and a will be nothing but this value, z minus a, that means z minus 3 by 2, so that will be 3 by 2. Now you check that whether 3 by 2 is lying inside the circle. So in here x square plus y square equal to 1 square means this is equal to 1, this is equal to minus 1, y value is minus 1, and here x value is 1, here x value is minus 1. So wherever you go, maximum you can go up to 1 and minus 1, and in along the x-axis you can go from 1 to minus 1 to 1. But here my a is 3 by 2. 3 by 2 is not lying inside the circle. 3 by 2 will be somewhere here. 3 by 2. A equal to 3 by 2 means it is a real value, and that is x. Because you see z equal to x plus iy. So x is the real part. So here I am having only real part. So that real part means along x-axis. And so this will be nothing but lying outside the thing. So if z by 3, z equal to 3 by 2 is, a equal to 3 by 2 is lying outside the circle, no need to do anything. The value of this one will be 0. So this means integration over c dz by 2z minus 3 will be nothing but 0. Will be nothing but 0. Since 3 by 2 is more than 1. My maximum, the closed region is a circle with center, origin and radius 1. But 3 by 2 is lying outside the circle. So that means the integration will be 0. If 3 by 2 will be lies inside the circle, then we can have something different. For example, same problem I will do for some other region. Say evaluate integration over c dz by 2z minus 3, where c is nothing but mod z equal to 2. So here, what is the thing? X square plus y square equal to 2, 2 square. That means it is a circle with radius 2, center at origin. So we can draw a circle with center at origin and radius 2. Radius 2. That means this way it is 2. It is 2. And in the negative side x-axis it is minus 2. On the positive y-axis it is 2. On the negative y-axis it is minus 2. Now here we can find that again I have f of z equal to half, like that only we will write, and a will be nothing but 3 by 2. So 3 by 2 is less than 2. 3 by 2 is less than 2. So that means 3 by 2 will be somewhere inside the circle. So if it is 2, 3 by 2 will be inside the circle. So this integral will be not 0. So what we will do then? This value will be integration over c dz divided by 2z minus 3 will be 2 pi I into f of a. F of a is nothing but 3 by 2. But f of z is 1 by 2. In the place of z, if I put 3 by 2, also no change because it is a constant function. And so what we will get here? 2 pi I into f of a is will be half, 1 by 2, and so finally we can get pi I. Okay, so same integral in some region it will be 0, same integral in some other region it will be non-zero. That depends upon the point whether lying inside the sea or outside the sea. Just I will do some other problem here. Say I will take here, I take here another example. Evaluate. See, we are not saying that use this formula, that formula. You have to select the formula depending upon the situation. Either you are going for the Cauchy integral formula or something else. Don't use whatever integration formula you know. Don't say log z or something like that. Okay. So evaluate integration over c cos pi z divided by z minus 1 into z minus 2, z minus 2 dz. Here what is my circle? My circle is mod z equal to 3 by 2, 3 by 2. That means our equation will be here x square plus y square equal to 3 by 2 whole square. So it is a circle with radius center at origin and radius 3 by 2. So you can have a circle here, center is origin and radius will be 3 by 2. Radius will be 3 by 2. So here I will have 3 by 2. Here I will have minus 3 by 2. Here I will have 3 by 2. Here I will have minus 3 by 2. Now, what is the integral given, whether the points are lying inside the circle or outside the circle, we will check. Okay, so here we are having two expressions, z minus 1 and z minus 2, z minus 1 and z minus 2. So one by one you can, there are two methods. You can first just split up z minus 1 and z minus 2 into two part, and then you can evaluate it. That is one thing you can do. And another thing, no need to do that one. If you do another thing, what is that one? Say, whenever I am taking this term into consideration, remaining thing I will consider as f of z. So solution, let me find the solution. Integration over C cos pi z divided by z minus 1 into z minus 2 dz. Say I am going to write a single term. So remaining thing what I will do, I will write this one in this way. Integrate I1 I will say. I1 will be integration over C cos pi z divided by z minus 2 whole divided by z minus 1 dz. Okay. So in that case, my f of z will be this one. My f of z will be this. Okay. So now let me check what is my a. So write a is nothing but 1. If a is 1, then what will be the remaining thing will be my f of z, this thing. So I will consider f of z will be cos pi z divided by z minus 2. Z minus 2. Okay. So now a equal to 1 lying inside or not, it is a 3 by 2. It is 3 by 2. That means definitely z equal to 1 will be somewhere here, because 3 by 2 is 1 is less than 3 by 2. That means this one is lying inside the circle of radius 3 by 2, and so the integration is non-zero since it is lying inside the C. So what we will do then, I will find f of 1. I will find f of 1. F of 1 will be cos pi, because z equal to 1, divided by 1 minus 2. That means minus cos pi. Minus cos pi. Then what I will say is I1. Now I1 will be integration over C cos pi z divided by z minus 2 whole divided by z minus 1 dz will be equal to 2 pi I into, since this one belongs to the circle, so I will write f of 1. But already you found f of 1 equal to minus cos pi. So this means 2 pi I into minus cos pi. But cos pi is equal to minus 1. And so minus of minus will be plus. So your answer will be 2 pi I. So you can leave here also. Otherwise you can put the value of cos pi, and that will be nothing but 2 pi. So this happens when a equal to 1. But we have another point there. Here another z minus 2 is there. Suppose I am considering a equal to 2. Then, so at a equal to 2. At a equal to 2, how can I write the integral? Integration over C cos pi z. I will keep z minus 2 in the denominator. All other things will be numerator. So I will take z minus 1 above, and denominator will be z minus 2 dz. Okay. So this will be now my f of z. This will be now my f of z. So what I will consider, my I2 will be integration over C cos pi z divided by z minus 1 whole divided by z minus 2 dz. Okay. So this is equivalent to integration over C f of z divided by z minus 2 dz. Okay. So now what is our f of z? Our f of z is here. Our f of z will be nothing but cos pi z divided by z minus 1. And what is my a? My a will be 2. Whether a equal to 2 lying inside the circle or outside the circle, we will see. So 3 by 2. 3 by 2. So right, our circle is mod z is equal to 3 by 2 is a circle with center at origin and radius 3 by 2. But here you see that 2 is more than 3 by 2. That means 2 will lies outside the circle. If it is 3 by 2, 2 will be somewhere here. 2 will be somewhere here. So which is lying outside the circle. And so if it is lying outside the circle, what will be the value of this? The value of this will be nothing but 0. Since 2 is lying outside the circle. And so final answer will be I1 plus I2. I1 you got as 2 pi I and I2 you got as 0. So finally your answer will be 2 pi I, and which is nothing but this integral, which is nothing but this integral. This is the integral. The value of this integral is 2 pi I. Okay. So I will do another problem where the center will be some other things, and the circle will be some other thing. So say I will write here evaluate integration over c 3z square plus 7z plus 1 divided by z plus 1. Here I am not having z minus a, I am having z plus a. That means that one will be minus of minus a dz. And here what is my circle? My circle is nothing but mod z equal to half. Mod z equal to half means it is a circle with center at origin and the radius is half. So if I have a circle with center at origin and radius half, that means in this side it is positive half, in this side it is negative half, in this side it is positive half, in this side it is negative half. Now what is my a? What is my a? In place of, so we can write it in this way: integration over c, just I am solving it, integration over c 3z square plus 7z plus 1 divided by this z plus 1 can be written as z minus of minus 1 dz. So you see here a is equal to minus a. Now I will check whether minus 1 is lying inside c. So minus 1 means here minus half, here minus half, minus 1 will be more than this. So here this is less than minus half. So which is outside the cycle. So a equal to minus 1, a equal to minus 1 is lying outside the circle, outside the circle. Therefore, integration over c 3z square plus 7z plus 1 divided by z plus 1 dz will be nothing but 0. No need to evaluate anything. It is simply 0. Okay. I will do another problem where the circle will be not having center at origin. It will have the center somewhere else. So I will do such one problem. So question is evaluate integration over c z square plus 1 divided by z square minus 1 dz, where c is nothing but z minus 1 mod is equal to 1. So first try to understand what is the meaning of modulus of z minus 1. So we can say that z is x plus iy and minus 1. So minus 1 is the real part. So I can write x minus 1 in one place plus iy, then I will take the modulus. Modulus of this one, you know that x minus 1 whole square plus y square, and that is equal to how much? 1. That is equal to 1. So it is a circle which center? It is a circle C, z minus 1 mod is equal to 1 is a circle with center at center at 1 comma 0 and radius 1. So let us sketch the circle. So this is my xy plane, okay, and the center of the circle will be 1 comma 0. 1 comma 0 will be here on the x-axis. Here 1 comma 0. This is the circle 1 comma 0. Now radius is 1. Radius 1 means from the center I will take 1 here. That means it will be x equal to 2. It will be x equal to 2. And from the to the left also I will take 1. That means it will be 0. And but in case of y I cannot do that one. So I can take a circle like this. I can take a circle like this. Okay. So now whatever integral we are going to evaluate, whether the point lying inside the circle, this one, that is the thing we need to check. So here you see the original equation is not in the form of z minus a. So we have to make it into the form of z minus a. So what I am going to do here is I am going to do here like this, integration over c z square plus 1 and z square minus 1 is there, so we can write z minus 1 into z plus 1. So we have to make it linear factor so that we can apply the Cauchy integral formula. So now here I will have two values of a, one is 1, other one is minus 1. So let me take which one is lying inside, which one is lying outside. You see that z, maybe I am having two values. For this one I may have a equal to 1, and for this one I may have a equal to minus 1. So out of these two, which value is lying inside the circle and which value is lying outside the circle, we will see. So z equal a equal to 1 is nothing but here x is equal to 1 is here, so this point is lying inside the circle. Now if I take a equal to minus 1, that will be negative side of to the x-axis. See, these are real values, that's why I am saying whether lying inside the circle or not lying inside the outside the circle, that depends upon the x-axis. These are real. If instead of this I will get I minus I, then I could have checked I means x plus iy. Only I is there means x is 0, y is 1. So I can check here if it is imaginary, okay, or I can check here if it is minus imaginary. Since I am getting both the values are real, so I am checking along x-axis along. I am checking x-axis along. So out of these two, a only one will lies inside, so right, out of 1 and minus 1, a equal to 1 lies inside C. Therefore, what I will do, integration over C z square plus 1 divided by z plus 1 I will take above, and remaining thing I will make z minus 1 dz. Now can you able to tell me what is your f of z? This is equivalent to integration over C f of z divided by z minus 1 dz. Now can you tell me what is your f of z? Compare and tell me. So here I have z equal to a, and our f of z will be nothing but z square plus 1 divided by z plus 1. Okay, so now the integral of this one will be nothing but 2 pi I into f of 1. into f of 1. Since we know f of z, we can able to calculate f of 1. So what is my f of 1 then? F of 1 will be 1 square plus 1 divided by 1 plus 1. And so we will get 2 by 2, that is 1. And so what will be the integration of this? Then integration of this one, integration over c z square plus 1 z plus 1 divided by z minus 1 dz, which is equivalent to saying integration over c z square plus 1 z square minus 1 dz, and that is nothing but 2 pi I into 1, and so we will get 2 pi I. So this is the procedure to evaluate some complex integral using Cauchy integral theorem.